Good morning. In this lecture, we discuss some other examples on iterated limits. So consider one more example on iterated limit. F of xy is equal to x sine 1 upon y plus y sine 1 upon x. Whenever xy is not equal to 0, 0, otherwise is equal to 0. So we have to calculate limit x tends to 0, y tends to 0, f of xy. So consider one example, limit x tends to 0, limit y tends to 0, x sine 1 upon y plus y sine 1 upon x. Now putting y is equal to 0, in this case, putting y is equal to 0, remains only limit x tends to 0, x sine 1 upon y plus y sine 1 upon x. Okay, so here we get sine 1 upon y, but sine 1 upon y, value of y is equal to 0. Value of y is equal to 0 means 1 upon 0 is infinity. 1 upon 0 is infinity and sine infinity is infinity. So value of this limit, that is x sine 1 upon y, is infinity, and here plus 0. So value of this limit is limit x tends to 0, infinity plus 0. Since sine 1 upon y does not exist whenever y is equal to 0, when value of y is 0, 1 upon y, that is 1 upon 0, is infinity. So sine x sine 1 upon y, this limit has value infinity, plus y sine 1 upon x has limit 0. So limit x tends to 0, infinity plus 0, that means infinity. Infinity means limit does not exist. So first limit is does not exist. Now next one, limit y tends to 0, limit x tends to 0, f of xy. Now we have to first calculate limit x tends to 0. So putting value of x is equal to 0 in this equation, the first term x into sine 1 upon y is 0. But y sine 1 upon x, here again substituting value of x is equal to 0, we get sine 1 upon 0, and sine 1 upon 0 is infinity. Since 1 upon 0 is infinity, so second term has value infinity. So you get limit y tends to 0, 0 plus infinity is equal to infinity. That means limit does not exist. So in first case also we get limit does not exist, and in so second case we get limit does not exist. This means iterated limit of this function is not exist. So we check continuity of that function. For continuity, we consider for epsilon greater than 0, there exists delta greater than 0, such that norm of xy minus 0, 0 is less than delta. Norm of xy minus 0, 0 is less than delta means by definition square root of x square plus y square is less than delta. Now we have to calculate the function is continuous or not. So we considering the modulus of f of xy minus f of 0, 0. Here value of f of 0, 0 is 0. We have given that function f of xy is equal to 0 whenever xy is equal to 0. So value of f of 0, 0 is equal to 0. Right? So function f of xy has x sine 1 upon y plus y sine 1 upon x. So this separating mod less than or equal to modulus of x into sine 1 upon y plus modulus of y into sine 1 upon x. But all of you know that this is I left it written as this is less than or equal to root x plus root y. So what about that sine 1 upon x and modulus of sine 1 upon y? All of you know that we solved this example in previous lecture, that is continuity of the to calculate continuity of the function or to check the continuity of the function. In this previous lecture we solved this example. You remember that sine value of sine and cos are lies between -1 and 1. So therefore modulus of sine 1 upon x is less than or equal to 1, or modulus of sine 1 upon y is also less than or equal to 1. So values of this sine 1 upon x and cos 1 upon x values are less than or equal to 1. So therefore here remains only modulus of f of xy minus f of 0, 0 is less than or equal to root x plus root y. Okay. Since here in this case, remember here modulus of x sine 1 upon y and modulus of sine 1 upon x, both these mod having the value less than or equal to 1. So here remains only mod x plus mod y. Okay, now understand? Okay, so you know that mod x is equal to square root of x square and this condition is less than or equal to square root of x square plus y square, which is less than delta. Similarly, mod y is equal to square root of y square, which is less than or equal to root x square plus y square, which is less than delta. Means this term is less than or equal to this delta plus delta, which is equal to 2 delta. Okay, this delta is, we have to replace the delta with epsilon. Okay, so by choosing delta is equal to epsilon by 2. So by replacing here delta by epsilon by 2, we get this mod f of xy minus f of 0, 0 is less than epsilon. Therefore, the function f of xy is continuous at 0, 0. Okay, these are some examples of for homework. Try it independently, and if you have any difficulty, then ask me later. Okay, you understand that if iterated limit of the functions are exist, if they are equal, the function is also continuous. If iterated limit does not exist, then also function is continuous. So we can't say the relation between iterated limits and continuity. If the limit does not exist, then the function is not continuous, but the limit are exist and but the limits are exist, but they are not same, then the function is also continuous. Okay.